Hello, everyone. Thank you so much for joining. So today I'm going to talk about a vulnerability in Active Directory. So this vulnerability was found in a new feature called dMSA. And now, before we talk about dMSA, let's talk about the background. So dMSA is a type of a service account, but before dMSA was introduced, we had legacy service accounts. So legacy service accounts are accounts that we configure for a service to run with in Active Directory. And this type of accounts, legacy service accounts, has had some major security risks. And the most relevant one is that they are a target for an attack called Kerberos. Now, in 2008 and 2012, Microsoft introduced a new type of service accounts. So managed service account, so MSA and dMSA, and this type of account actually solved the problems that the legacy account had, but there is a new problem now because not every service supports MSA and dMSA, so we can't just configure every service to run with MSA, and therefore we must still use legacy service accounts in our organization, which means that we are still a target for Kerberos. And the other part is that to configure, to take an existing service that do support MSA and to configure it to run with MSA instead of the legacy service account, it requires a lot of work. And if the IT team will make a mistake, the outcome will be that there will be a service that will just not work, and this may be critical. So that's not good. But luckily for us, just recently, in 2025, Microsoft introduced dMSA, which is Delegated Managed Service Account. And so it's brand new, and it has all of the advantages that MSA and dMSA had. But this time, the IT team can just lay back and relax, because now there is a really new cool migration process that lets you take an existing legacy service account that is configured for a service or multiple ones and just migrate it into a dMSA. And now this dMSA will be used for every service that used the legacy service account, and it doesn't even matter if the service supports MSA or not. It will still work with dMSA. So that's amazing. And the second part is that now the IT team don't really have to do anything. They just start the migration, complete it, and that's it. So it's amazing. So let's let's talk more about this migration process. Now, I won't go into full details. I will do that in my full presentation in DEF CON, but for now, let's just focus on the important parts for now are that we need to start a migration, and when we do, we have two accounts that are being linked, and some configurations are being made on the two accounts, and then we wait for a couple of days, and we complete the migration. And at this point, the legacy service account is getting disabled, and again, some configurations are being made, and everything works great. And these two slides were from Microsoft documentation, basically. So Microsoft documentation describes how the migration works and which configurations are specifically being made on the two accounts. But there was just this one thing that Microsoft documentation didn't mention at all, and this is a pretty critical thing. So that is privileges and permissions. So Microsoft documentation just didn't mention the privileges at all, and if we had a legacy service account, and this legacy service account had some privileges in the domain, and maybe it was privileges that the service needed, and now we have a dMSA, we need the dMSA to have the exact same privileges. So let's talk a bit about privileges in Kerberos. So in Kerberos TCAT, we have a structure that is called the PAC, and The pack is a structure that contains some information about the user, and it also contains the list of every group that the user is a member of. Now, if we had the legacy service account, which was a member of several groups, and I have now created a new dMSA and completed the migration, and I checked, and the dMSA is not a member of any group, I can expect the dMSA pack to look like this. But that will mean that our service will not be as expected because they don't get to use the same permissions as before. But apparently, that's not the real case. The pack of the dMSA actually looks like this. So what happens here is that when the DC is building the pack for the dMSA, it will build the pack just as with every normal user, but then it will check if the dMSA is linked to another account, and if so, it will also build the pack for the other account, then just merge the two, so the dMSA will have, the pack of the dMSA will list the membership of the dMSA and the legacy service account, and therefore the dMSA will have the same permissions. So that's great, but when we saw it, we thought that this is really interesting. I have never seen any mechanism in Active Directory that allows you to just the permissions of one account, give it to another, and without changing any group membership. That's really cool. So we wanted to know if we can abuse it, and in order for that, we started with trying to understand how the migration works. So in order to start a migration, we need to execute this PowerShell commandlet. And we tried executing this PowerShell commandlet without domain admin's rights, and well, we failed. So we wanted to know what happens when we we wanted to know what this PowerShell commandlet actually is doing, and this is basically just a wrapper for this migrate AD service account. This is an LWDSA DSA operation. It's basically just a request that is being sent to the DC. Now, we tried manually sending this request to the DC without domain admin rights, and once again, we failed. So the reason for that is that the DC has a verification, and it actually checks if the caller is a domain admin or not. And if we're not domain admin, we will fail. Yeah, so that makes sense. But then we wanted to know what the DC is actually doing when this functionality gets invoked. So all the DC does is just changing some attributes. So at this point, we stopped for a second, and we thought that maybe we can just change the attributes ourselves without actually triggering the migration process. So what if we can just write to the same attributes as the migration process does, and just link the dMSA to another account? So that means that we are currently having control over a dMSA, and we link it to another. Well, that's actually, that just worked. So if we have control over the dMSA, we can link it to any account. It doesn't matter if the account is in the privileged users group, or if it's configured for not allowed for delegation, it will work. So that leads us to BadSuccessor. So BadSuccessor is the name of the technique that exploits this vulnerability. And so let's take a look at the attack flow for BadSuccessor. So we start with an attacker that has control over a dMSA, and the attacker wants to gain domain admin privileges. So what the attacker needs to do is to simulate a dMSA migration, so link the dMSA to another account, to a domain admin. Then the attacker will need to authenticate as a dMSA, and the DC will just grant the privileges. So that's amazing, but to gain control over an existing dMSA, that's actually pretty hard, because dMSA has just been introduced. Organizations don't use it yet. So that's hard, but apparently, if the attacker has a control over an OU, the attacker can just create a dMSA. So the dMSA can be created in any OU, and OU it's basically a folder in Active Directory, and there are some folders that maybe the IT admin thought that, well, this folder is not so important and we can just grant overly permissive permissions there. But no, this is critical, because if the attacker has permissions over an OU, they can create a dMSA, and therefore they can simulate a dMSA migration, and that's it, and gain domain admin. So that's really cool, and we have reported this vulnerability. Okay, so sorry about that. Let's see a demo. Okay, now it's stuck. Okay, so we are running as a weak user, and we will try to add ourselves to domain admins, but we fail as we are a weak user. We do have permissions to create objects in an OU called temp. We use it to create a dMSA, and now we link this dMSA to the administrator account. Great, so we are now linked to administrator. We will authenticate as the dMSA. We will use the Rubius tool for that. And now, running as the dMSA, that's great. We will try to add a member to domain admin once again. This time we succeed, as we are running with the administrator privileges. So we have reported this vulnerability to Microsoft. I hope so. Yeah, okay, we have reported this vulnerability to Microsoft. And they said that they agreed that this is a vulnerability, but they said that this is a moderate severity one, and therefore it does not meet the bar for immediate servicing. They did, however, said that they are going to fix it in the future. So stay tuned. And so for now, there is no mitigation. And that's actually not the end of the story, because when we started the research, I saw this structure. So this structure is inside the TGTs for dMSAs, and basically it holds the current keys and previous keys. So these are Kerberos keys for the dMSA. Basically, this is just the dMSA credentials. So when we authenticate as the dMSA, we will get the credentials of the dMSA, both the current one and the previous. So when I saw it, I thought that it makes sense, and I didn't give it any attention until I saw this response. So what we can see here is we have current keys and previous keys, and this dMSA is the dMSA from the demo. So I have just created this dMSA, linked it to administrator, and I saw this response, and this really caught my eye. So the thing that I actually missed when I saw it is that there is something in the previous keys, and that's weird. This is a new user that I have just created. They don't have a previous password. But the thing that did caught my eye was the value actually inside the previous keys. So this is a value that I know really well, and I don't use. And this is an NTLM hash. I don't usually just recognize a random NTLM hash, but this one is the NTLM hash of a password that is really important to me. This is the NTLM hash of this password, which is the password that I always use for my lab environments. So when I saw it, I immediately recognized it. I saw this NTLM hash a lot of times. So what actually happens is when we link the dMSA to another account, we are not only gaining their privileges, we are also gaining their credentials. So that's amazing. And this password was the password I configured for administrator, as, again, I always use this password. Okay, so I have created a tweet about it, and I show that I execute some PowerShell script, and then it will just dump the credentials of any user or computer in the domain, including the Kirby TGT account. You can't see it here, but it's here. And this is like the most critical user in Active Directory. So yeah, this is just moderate, apparently. And okay, so let's talk about conclusions. So this is a new feature that was designed for security with security in mind, but apparently it doesn't mean that the feature itself is secured. The next one is to never skip the obvious, because when I saw this pack merging thing, I talked with my manager about it, and he said, maybe you can just change the attribute and link it to another account. And I was like, no, that will be way too easy. But it worked. It was just way too easy. And so the next part is that defenders should log and alert on dMSA creation and links. And the final one is that dMSA is a great new feature. I really love it. When Microsoft will patch it, I hope that every organization will use it because it's just great. And that's all. Thank you so much. Hope you enjoyed.